It feels like the AI landscape shifts every single day, but most of the time it's just small adjustments. This one feels genuinely different. DeepSeek V3.2 isn't just smart in a general sense, it's like a highly specialized professional engineer trained to spot the exact moment your code logic just collapses. It can instantly see a classic logic trap, that kind of recursive error that freezes an entire app, and fix it faster than a human can even find the line number. This is really changing the core loop of how we do technical debugging.
Okay, let's unpack this. Welcome back to the deep dive. Today, we're on a very focused mission to deep dive into DeepSeek V3.2, which is an AI model that's generated some serious, very tangible tech buzz. And the sources you shared with us, they're not about theoretical benchmarks. They detail these extensive real-world stress tests. So our mission is to really distill whether this model lives up to the professional hype, especially when you throw complex, hands-on technical work at it. And just for anyone catching up, an AI model is simply a system trained on massive data sets to process information and predict a useful output, like code or language. Beat. We need to know if this new output is just better sounding or if it's fundamentally more reliable. So here's our roadmap. First, we're going to look at its core intelligence and the massive memory upgrade it got. Then we jump straight into the practical stuff, its hands-on coding and debugging skills in building real applications. We'll test its logic, its math. And finally, we'll put it head-to-head with what everyone thinks is the top-tier competitor, GPT-5.
Yeah, and when you look at V3.2, you really see it represents a shift. If other generalist chatbots are, fantastic at talking about literature or just chatting, DeepSeek V3.2 is like a professional software engineer. It's specialized, it's precise, and it's almost obsessed with structure. I think the main reason the sources highlighted it is its reasoning capability. And this isn't just about pulling answers from a huge database. It actually builds a step-by-step internal chain of thought. So instead of just guessing, it analyzes the problem sequentially. And that's absolutely critical for solving complicated technical problems where every step depends on the last one.
That structural approach, it seems like it's intrinsically linked to that major memory improvement we saw mentioned. I mean, older models would get that prompt drift, right? They'd lose the thread halfway through a complex request.
I agree completely. It feels much more awake, like you said. The sources really put this improved memory to the test. They gave it a 3-part directive. Write a piece of code, then explain that code line by line, and save the final output as a specific file format.
And it managed all three without needing a correction.
Perfectly. Seamlessly. It showed that structural logic. Okay, I must do task A, then immediately explain the result of A in task B, and finally I execute the save command in task C. That ability to just logically sequence these multi-part requests, it saves developers a huge amount of time. It gets rid of that constant repetition you have to do with less structured AIs.
How important is that improved memory for real-world tasks?
It's critical for any multi-step project. It just stops all those repeated requests.
Okay, if it can handle complex instructions, let's see how it handles complex execution. Here's where it gets really interesting, moving into the coding challenges. They didn't just test basic functions. They ran a GUI application challenge. Build a working Pomodoro timer with Python's Tkinter library. And the task required precise timing, start and reset buttons, audio cues, and even changing the background color green for work, blue for the break. That's a whole application.
Oh yeah, that is a classic stress test for event management. Building a GUI means you have to manage the event loop, which is the critical system that, keeps the application responsive and stops it from just freezing while it waits for a command.
And this is where that precision really showed up. The sources confirmed V3.2 handled the event loop perfectly. It used the Python after function and did it accurately.
And that's so important. The .after function lets the timer update every second without stopping the rest of the application from running. It prevents it from blocking or freezing. A more generalized AI, it might try to use a simple sleep command, which is a guaranteed way to crash a GUI. DeepSeek understood the non-blocking nature that an application structure really needs.
And for any developer looking at that code, the comments must save so much mental overhead. The sources pointed out that DeepSeek added these little line comments explaining why it chose a specific function, or even why it chose a color. That level of documentation is exceptional for someone who might be learning or, needing to integrate that code later on. I'll be honest, I still wrestle with prompt structure sometimes when I'm trying to build full applications. It's just so easy to lose the thread or miss an edge case. So seeing a model handle that complexity and documentation detail is genuinely impressive.
Absolutely. And that precision, it carried right over to debugging. I mean, writing new code is one skill. Debugging someone else's broken structure is a whole other thing. They tested it with a classic logic trap, an infinite loop where the variable x just keeps increasing while the condition, while like 0 is always true. It was designed to never, ever stop. This isn't just about fixing syntax, it's about predicting how the computer's resources are going to be used. V3.2 spotted the error instantly, fixed the code concisely, and then explained exactly why that loop was infinite. It was like a patient teacher pointing straight to the root of the problem.
And that demonstrates real structural insight. They also checked its ability to interact with web environments, right? Moving to JavaScript and HTML. The challenge was creating a to-do list that used local storage.
Right, and local storage, for anyone unfamiliar, is basically the browser's memory bank. It lets an app remember details even after you close the tab. It requires understanding how browsers manage memory, not just, rote coding.
And the result?
Smooth execution. It correctly wrote the function to save data to the browser's memory, and when they tested it, the tasks were still there after the browser was closed and reopened. That proves a deep structural understanding of how applications actually interact with the environment they run in.
So what did that Pomodoro test really prove beyond just coding capability?
It proved a deep understanding of event loops and real application structure.
Okay, so if that structural thinking works for code, let's see if it holds up when we move from syntax to just pure human logic. Logic riddles are the perfect stress test for a chain of thought system, especially one with a twist. They use the classic far, wolf, goat, and cabbage river crossing riddle. We all know the trick, right? Many AIs can move items across, but they fail at that crucial step of bringing an item back to make room for the next safe trip.
And DeepSeek V3.2 nailed that sequence. It correctly listed all the steps, including that necessary, kind of counterintuitive action, bring the goat back to the original side. That little detail proves it's maintaining a strong internal reasoning system through the whole sequence.
And that sequential accuracy also extended to complex financial math, which can be a huge weakness for language models. The problem was a multi-step pricing scenario. A $20 item, you take a 15% discount, then you add a 10% tax, but it's calculated on the discounted price.
Yeah, that requires dependency management. Step B depends on the result of Step A, and Step C depends on B. V3.2 correctly broke down the steps, calculated the discount first, then the new subtotal, and finally the tax, and it got to the correct final price reliably. That capability is key for any office worker or student who's relying on quick, accurate calculations.
Okay, but reliability also means honesty. We talked before about the challenge of AI hallucination, where models just invent facts when they don't know the answer.
Exactly. So the sources tested V3.2 with a clear trick question about a totally fake event. Tell me about the event where Elon Musk landed on Mars in 2021.
A deliberate attempt to poke a hole in the truth filter.
And V3.2 just rejected the premise instantly. It responded, there is no factual basis for this event. Elon Musk did not land on Mars in 2021, and no human has ever landed on Mars. It just refused to fabricate information to please the prompt. That ability to prioritize factual accuracy is a massive plus for research integrity, for technical support. Anywhere that a made-up solution could be catastrophic. Whoa. I mean, imagine scaling this type of reliable logic and speed to 1 billion developer queries a day. The efficiency gains across the entire industry would be just astronomical.
Why does a strong truth filter matter more than, say, creative writing?
It ensures research reliability and just avoids fabricated, potentially harmful information.
A factual, non-hallucinating assistant. That really is the dream. It does make you wonder how this specialized, very precise model stands up against the generalist powerhouse GPT-5. So we've seen DeepSeek V3.2 perform with incredible accuracy on these specialized tasks. So what does this all mean when we stack it up against the perceived strongest competitor?
The analogy in the source material is, I think, perfect for understanding the difference. DeepSeek is the race car, and GPT-5 is the luxury sedan. Both are excellent, top-tier performers, but they're engineered for different purposes and for different drivers.
Okay, let's use that analogy. Let's break down the features for our listeners.
Okay, start with speed. DeepSeek is extremely fast. It's the race car winning the sprint. GPT-5 is fast, but if you're using an API or hitting it during peak hours, you might experience some lagging, a little traffic jam. Second, cost. DeepSeek is generally cheaper for large-scale API users, which is critical if you're running, say, 1,000 developer queries an hour.
So we're talking function and efficiency versus maybe broader capabilities. What about the actual output, the code style?
In code style, both are excellent, but their tone is different. DeepSeek is precise. It strictly follows syntax and structure. It's the perfect, rigorous engineer. GPT-5 is also excellent, but sometimes it offers a more creative solution or maybe an alternative, slightly less used library. It's the comfortable luxury sedan offering more amenities.
And I'm guessing that difference in tone translates to general writing, too.
Yes, exactly. DeepSeek is good, it's straight to the point, and it's highly factual. GPT-5 is often described as a little more flowery, a bit smoother, maybe better for marketing copy or, nuanced essays. The race car is built for speed and engineering. The luxury sedan is built for comfort and a wider appeal.
So for our listeners, who should choose the race car model?
Programmers and engineers. Anyone needing speed and accurate syntax execution.
Okay, so that brings us to the big idea recap. DeepSeek-V 3.2 is an incredibly reliable, specialized tool. It represents a real advancement in specialized technical thinking, in debugging, and in precise logic. It's a legitimate step forward for technical productivity because of its reasoning system.
But the power of any tool really depends on how you use it. The sources were very clear that even with this advanced reasoning, you have to talk to it correctly. They shared a crucial prompting formula for getting the most out of it.
Right, you can't just be abrupt and expect perfection. You need structure, which is what the DeepSeek model itself seems to thrive on.
Exactly. They recommend the context task format structure. It's like stacking Lego blocks of data. First, you give it a role so it knows what perspective to use. Context. You are a senior marketing expert. Second, be ruthlessly clear about what you need done. Task. Write 5 ad headlines for our new platform. Third, specify the output so it's actually usable. Format. Present the results as a numbered list. That simple structure really unlocks its precision.
And that's actionable advice our listeners can apply right away.
And finally, there's a necessary disclaimer. Always double-check the results. Even with this level of reliability, you have to run generated code in a draft environment first. For generated text, I always recommend reading it out loud. Sometimes the AI uses words that are just a bit too formal or stiff, and a quick edit makes it sound much more natural.
That feeling, though, when your code runs smoothly on the first try, and you didn't just spend 3 hours debugging a simple loop, it's deeply satisfying. And DeepSeek-V 3.2 seems designed to deliver that satisfaction more consistently, especially for technical users. So here's a challenge for you this week. Grab the specs for that Pomodoro Timer, 25 minutes work, 5 minutes break, the color change, the sound cue, and try prompting this model yourself. See if DeepSeek-V 3.2 can truly save you a few hours of debugging and restructuring this week. Thank you for sharing these incredibly detailed sources. This was a fascinating deep dive into the specialized future of AI.